All right, so we've found both complex numbers in polar form, and so I've put them over on the right. We've got 2 cis negative 30 and root 8 or 2 root 2 cis negative 135. Hence, find the exact value of cos 105. So I'm looking at the angle 105 and saying, how can I get 105 from 135 and 30? So if I just play around with that, I know that there we go, 105. Or perhaps negative 105, because cos is an even function. So cos of negative 105 should be the same as cos of 105, since we're dealing in negatives. So I've got negative 135, and if I subtract negative 30, so that's adding 30, you can see I would get negative 105. So that's what I want to do with these two. So using de Moivre's theorem. So what I can do is say, okay, let's have a look at which one was 135 at 2 root 2. So if I go 2 root 2 cis negative 135 and I want to subtract, so we know that means divide if we want to subtract the angles. So the other one was 2 cis minus 30. So actually, just to make it easier, let's call this I won't it right. Here we go. I'm going to call that one Z and I'm going to call this one W. So what I can say, which one did I do on which one? Ooh, W. W on Z. Yeah, W on Z is that. And that equals, so we can cancel the 2's and we've got root 2 cis. And with the angles, we subtract. So we've got negative 135 minus 30. So we get root 2 cis negative 105. All right, now think about that. That has cos and sine in it, and we're only looking for the cos part. So if we take the real part of that, you can see we're going to have root 2 cos negative 105. Instead of that, we don't want the plus I sine part. Now, remember, cos is even function, so that would be cos 105. Okay, I'll just write since cos, I'll just write negative theta equals cos theta, or because cos is an even function. All right, so that doesn't get me the exact value. That's just how I'm going to use them to get the exact value. So I know that W on Z is that. So now go back to our Cartesian form, and I can say, well, W on Z is, what's W? W is minus 2, 1 plus, I'm just going to factorize by that negative 2. And Z is root 3 minus I. Of course, so I want the exact value. I want to rationalize. So I'm going to multiply by root 3 plus I on root 3 plus I. So of course then on the bottom, I'm going to get 3 take away plus 1. So take away 1, so 4 on the bottom. So I've got 4 on the bottom. I've got minus 2, 1 plus I, root 3 plus I. Oops. So again, I can do a bit of cancelling, divide by 2. And I can now have, so I've got negative, I'll put all on 2 here. Let's say I've got a root 3, I've got a root 3 and a negative 1. And then I've got a root 3i. And I've also got an I. So I've got all of that. So again, if we just take the real part of W on Z, that's all I want, right? Because that's what I had here. So just take the real part and you can see you're going to get negative 1, so positive 1, and negative root 3 on 2. Now if we equate those, because they're exactly the same, so they should be equal to each other. So equating, we've got root 2 cos 105 is equal to 1 minus root 3 on 2. So let's divide by root 2. And then, of course, we want to times by root 2 on root 2. And then we can see we've got root 2 times root 6 on 2 times 2 is 4. Okay, so that's how we go about using our Z and W in Cartesian form or in polar form. Both Cartesian, we're using Cartesian and polar form and equating to find the exact value.